privilege to welcome you to the astronaut training facility. You're seeing here in front of you, specifically looking here at the Mako of the International Space Station, you're seeing here in front of you one of the largest classrooms in use by our scientists, astronauts, and engineers as they develop new hardware and new training procedures for that hardware, and then practice with it before they take it up and actually use it for real, so to speak, in outer space. So, you can see here, it's a full-size Mako of the International Space Station. Everything inside of it is exactly the same as it would be on board the actual space station. So, after astronauts practice here, when they get up to space, they feel right at home. So you see here in front of you, as I mentioned, the Mako of the International Space Station. The International Space Station is, of course, international. It's a partnership of 15 nations, each with their space agencies, or space programs, if you will. Our own NASA, Russia's RSA, the European Space Agency, which is a sort of a conglomeration, a group effort of several European nations, Japan's space agency, as well as that of Canada. And these nations and their agencies provide and operate the different parts, so to speak, of the International Space Station, the different pieces of equipment. Now, to the back and the left of the ISS mock-up, if you look sort of directly across from us, it's right there on that back wall, you see a black boxed-in area that says Mission Operations on it. It's got a Mission Operations logo on it. This is the Precision Air-Bearing Floor, ladies and gentlemen, also known as the PAB-F, because we love our acronyms here at NASA. And the PAB-F operates much like a giant air hockey table. So if you think about that air that pushes up the puck, operates like that, except giant. It allows our astronauts to practice moving objects in a frictionless environment, objects which may very well weigh several tons, because they will be required to move such large objects in space. Now you might be thinking, yes, that's the case, but in space all those objects are weightless, so what's the big deal? Why would you need to practice? Well, ladies and gentlemen, while it is true that all those objects are weightless in space, so it is pretty easy to get them moving. You might remember way back to physics. I remember that Newton's laws are pure in outer space, so objects in motion tend to stay in motion without friction to slow them down. So while it's very easy to get objects started moving, especially very large objects with a lot of mass, it's difficult to slow them down. So that's why those astronauts need to practice here before they go up into space and do it for real, so to speak. Now, if you look in front of us, you can see two white Russian monsters. We have Spacccce on the left and Zarya on the right. Now, I really want to draw your attention to a Russian capsule, which is between us and those two white compartments there. We have the sort of, it's vertical, grayish green, sort of beige capsule. This is the Russian Soyuz capsule, ladies and gentlemen. Unlike the capsule systems developed by the U.S. for our Mercury, Gemini, and Apollo programs, which all splash down, this Russian capsule is designed to land directly on dry land. Now, in order to do that, of course, it is slowed down from re-entry velocity using the complex system of parachutes as well as retro thrusters, which serve as small rockets pushing against that downward motion, slowing it down. Nevertheless, when it does land, it actually impacts at a rate between 20 to 50 miles per hour. So in order to keep all of our astronauts safe during that landing, we use they're known as couches, but they're basically chairs where the astronauts are kind of lying on their back, and each chair is matched to the contours of an individual astronaut's back to make sure they have a very safe and really relatively comfortable landing despite a pretty sudden stop there. At present, the Soyuz capsule is our primary mode of transporting up to 3 astronauts either to or from the International Space Station. So we have to ship our astronauts over to Russia, and then they send them up for us. However, we are going to be sending our astronauts directly from the U.S. to the International Space Station once again, but we're turning that task over to private industry. So companies such as Boeing, Sierra Nevada, and Spacccce are all developing different systems for transporting our astronauts to and from the International Space Station. By allowing private industry to operate that portion of the space program, by allowing them to take over that task, it allows NASA then to refocus our energies and our resources back on going beyond low Earth orbit. The International Space Station is very important. We're learning more every day, but it is only in low Earth orbit, ladies and gentlemen. We want to go back to the voyages beyond, back into deep space. Places like potentially the moon again, or an asteroid in our solar system, eventually the moons of Mars, and one day Mars itself. We'll be talking a little bit more about going back into deep space as we continue our tour here in Building 9. If you please follow me. Thank you.
TV. See?
It's amusing to me that it's such an old TV.
It's like binoculars. It's like binoculars. I'm taking.
Use the phone.
Well, you can't play game.
Alright, Wesley, in about 5 minutes you're gonna get the phone out. My phone's dead.
Why?
She went up that way. You wanted to get away from crying kids.
It's like binoculars. Because you can zoom, it's like binoculars. That's
It's a
neat.
much more modern TV.
Let me see. Oh, yeah.